Hi. Good morning. How are you? I hope I find you well because closing the end of semester, it will be sleepy and tired, and because of many projects and assignments and stuff. So I hope you are still awake because today is probably ending our main pursuit of theory, and after that, the next week we'll cover not yet. By Friday, we'll cover ANOVA and regression, which is applying what we have been doing so far. So most likely that we're going to finish all the journey for the theory part, and then we will have a more interesting thing to apply. And hope by then you know what's going on in statistics, and very likely that for many of you, it will be probably the last class you touch statistics. But I hope the things you learn will carry with you because that is using data to understand the world is the usual techniques that you face in business and other applications. So without further ado, so let's continue to talk about hypothesis testing. Just to remind you one thing, what is hypothesis testing? You learn estimation in the last topic, right? The idea was that we try to understand what's going on in population, and to do so, we collect data, right? And we call subsample, right? The sampling, with a sample, we get the small picture try to infer from big picture, right? To recall the leading example is the fact that suppose you are working for Elon Musk, who are trying to sell his new phone, might be called X phone, to mainland China, right? You want to see how to set the price, right? To see whether to go ahead. And you know, to say in China, with population of 1.4 billion, you can't really ask for 1.4 billion people, right? And that is not cost effective. So you have to only ask for a few thousand or even 10,000 people is very costly already, right? So probably you would want to at most at that level. And in that case, you have to choose what you have to study, right? And that comes from estimation, right? You are trying to do a random sample. Hopefully the sample will be representative for what happened in China, right? So that is the idea. And to recap, it's like what you are trying to do is you try to using a small picture to guess what happened in the big picture, right? That's the idea. So about first testing is like exactly or more or less opposite case. We have some knowledge about the population or the big picture, and we try to see the data support it or not. Okay, a reverse process, right? So an example would be, as far as I said, right? I have a drink, right? And like this, and I want to see, right, whether the claim, what we know is whether support data or not, right? And this is like 250 milliliter, right? You want to see whether accuracy is 250 milliliter, right? And also the claims low sugar, right? You want to see as a product control, quality control, or consumer counsel, whether it's actually low sugar, right? Or it has a claim to have enough vitamin C, right? Or enough lemon, right? It's lemon tea, right? You make sure there's enough lemon, right? Cannot be too high sugar, cannot be too low lemon, right? And it's 250, right? For safety of package. If you go beyond 250, you may explode, right? And if you below 250, then it's cheating, right? So it have to be exactly 250. So that's why you can see different kind of application, whether you want to be more than or less than, right? Or not equal to, depends on application. Okay. So just to quickly recap, right? Hypothesis testing is to test the claim on the population is correct or not. Okay, we have to take a stand whether to take it or not doing it. Okay, just have the two choice. Okay, and the thing that we will keep is called null hypothesis. We try to reject it. And if we reject, that will be the alternative. Okay. Just to remind you, the null is like in the courtroom, the defendant is not guilty. The alternative is the defendant is guilty. Okay. And you try to establish evidence to try to see if he's guilty beyond reasonable doubt. Okay. And for our class, we'll focus on the very simple case where the null is simple. The alternative is always composite. Okay. And in composite, we have two different ways. One is called one-sided, the other is called two-sided. Okay. And as I said, which to be used in which case, you should infer from the question or infer from application, right? Where the violation is more you need to see, right? And used to see you from the assignment should be very clear, and exam should be clear as well. If not clear, then you should be able to make your judgment, right? And for example, like this question, you should see, right? You want to see if greater than, right? So that will become your alternative hypothesis, right? So and if you want to check, right, in the case whether it's true, right, whether it's equal to 3,000, right, the revenue. If not equal to, that's a problem. So that is how you set up your null and alternative hypothesis. Okay. And the way often we do is to construct a test statistics, and we will say there's a critical value where it's a boundary of the value, whether it's more than or less than. Okay, we'll review quickly. But the main overreaching idea is we're looking at sample mean, right? If we are saying H1 is more than, right, that means that if the sample mean is too high, then you would favor this H1, right, over H0. Okay, similarly. Okay, but don't worry, we'll go to the example again. I hope this become clear. And just to remind you that we have two types of error. And in the way that we learn hypothesis testing, we directly control the alpha. Alpha is our choice. We have to decide what is the level of alpha accept, and that gives us a critical region, right, or critical value. And alpha is often 10%, 5%, or 1%. Okay. And beta is we can't control. But do note that if we choose bigger alpha, we will lower beta. If you choose smaller alpha, you will bigger beta. So there's a trade-off. Implicitly, we don't know, but it has to be there. So there's no free lunch. We can't make alpha as low as possible. So the usual trade-off is 5%. I hope that is clear. P-value is the definition. We can keep changing our alpha, right, such that we just make to reject. Okay, so that is the definition. Okay. Let's go to this test. Okay. And we want to test the sample mean. There are two types of tests. If you know the sigma square, okay, or we have some good guess of that, then we are safely can use that test. If not, then we can do t-test. Okay. And do note that when we do t-test, there's a big assumption behind. Okay. Z-test, we can rely on law of large number, and that thing is become easy. But t-test actually require you to assume the underlying population is normal. What does that mean? We call our leading example of Elon Musk looking at willingness to pay for the phones to be sold in China, right? In that case, you have to assume people willing to pay in China is a bell curve. Okay, it may or may not satisfy, but of course, in the terms of 1.4 billion, I think the bell curve will be fine. Okay, should not be a big issue, but do note that we need to make some assumption. And you can check a textbook or other advanced tests. They will tell you how to check if that follow what we want, but it's beyond the scope of our class to talk about those. Okay. But let's go back to here. So let us recall the main idea of the Z-test. Okay, the Z-test is following. Okay, let's do slowly again, because as I said, this is probably the last class or last or 1 or 2 class that we talk about theory, right? After that, then basically application. Okay, so the main idea is the following. Okay, suppose we want to study mu, right? How do we do that? Right, the sample, the population mean, right? Then what we do is to look for the sample mean, right? Collect data. Okay, and we know because of sampling there's randomness. Okay, by law of large number, or if the underlying is normal, then we have a bell curve, right? And we know that the sample mean is unbiased, right? Actually, the center is actually this one, right? The bell curve is located exactly at the true mean. Okay, and we also know how the bell shape looks like, right? The bell shape, the variance is following sigma square over n, all right? And recall, what does that mean here? It means that we call the consistency, right? When n is big and big enough, the bell collapse, right? The bigger the n, the smaller the variance. Okay, you have more sample, actually your sample mean will be as close as mu as possible, right? Or large number, as we said, right? Bigger n, the bell actually collapse, right? And sigma square is how spread the underlying x is, right? The bigger the sigma, right, the more spread the data, underlying data, right? Of course, the sample mean will be more extreme, right? So this determines the shape of this x bar, right? So this will be mainly allocated around mu, but there will be some opportunity that outside, right? So how do we do this, right? And if we make the null hypothesis mu is a, right? If this is true, that means that this number become a, right? This is a, right? It's exactly a here. So let's use a to signify under this, under x now. Okay, so you see. Okay. Now the question is try to see if we have enough evidence to say this is right or not, right? Because this is the assumption, right? X now is true or not. We want to see if this is right or wrong. So in order to make decision, we need to know what is our alternative, right? What are the benchmark we're looking at, right? We consider first case this, right? Mu bigger than a. Okay. This means that we are saying that, okay, if we don't want to keep this, we should think about bigger than a, right? Much bigger. How big is bigger? We don't need to specify. As long as bigger, then we are fine. We just need to say it's bigger. So how big is big enough, right? The question is how big is big enough? So is here big enough? Is here big enough? Is it big enough? Okay, we have to come up with some criteria to say what's big enough. The idea is that, okay, what is big enough? Because we know probability, we can use probability to define what's big enough. Okay, the idea is that if this area is small enough, then that is big enough, right? And we call this area called alpha. Alpha is our benchmark we call big enough. And this alpha is exactly time on error. That's why I use the same notation. Why? Because even though H now is correct, okay, assume it is correct, it still has small possibility, that's alpha, that end up very big, right? Even this is correct, okay? So by deciding our alpha, we're deciding when to reject what is called small. Is that clear? So that is exactly why we talk about the significance value here, okay? Whether take it or not, we determine by our alpha, okay? So that is the idea. If this is big enough, then we will call it too big, right? So this number actually, you know, right? From what you learn is x bar plus z alpha sigma over root n, right? So whenever x bar, sorry, not x bar, it's a, sorry. So whenever what you get, X bar, is bigger than this, what we call critical value, then we'll reject, right? It's big enough, right? We do know that sigma we know, and we know, alpha is a choice, right? Then we're done, right? Just to remind you a little bit how to find Z of this guy, right? This guy, okay? Comment for Excel, right? Will be the norm, right? S inward 1 minus alpha, okay? Because inward, look at the area on the left, right? The right is alpha, the left is 1 minus alpha, okay? So that is the standard we do. And very often, we don't directly calculate this guy. Instead, we will work on what we call the Z score or Z test, is to convert it to what we call the standard normal, standardize it, okay? That means that instead of working in this, work on the Z, okay? And this becomes, A becomes 0, okay? And this number actually is Z alpha, and this area is actually alpha, okay? We actually compare the value Z, okay? Compare to Z alpha, okay? So it's bigger than Z alpha, reject. Less than Z alpha, you don't reject, okay? To remind you again, alpha is a choice, okay? Alpha is usually 5%, okay? But I can ask 10%, 1%, whatever percent I want to ask, I can ask, right? But that is the idea. Is that clear what we're doing? We'll go to example again, because it's very likely that you will forget since last Friday. So we just repeat the example again, okay, several times until we get it, because there has to be repeat for this one. Okay. Now, if there's no question, I will erase the screen and go to the next slide. Go to example. Okay. I hope there's no question. Now I'm going to clear the screen and go to the next one. Okay. So I go to example, then hopefully you would be fine with that. So the question would be the following. Okay. So it said the standard deviation is 4, okay, and sample size 64 and in 7. Okay. Again, this is our question. It's given. Okay. Now here I give you directly, but you expect the question will be given in verbal one. Okay. You should be expecting the verbal question will be asked. Okay. And the idea is the following, right? So you know this, okay? Follow normal distribution, so that's why it's a bell curve. Okay. And we know this is a bell. Under the null, this is 6 here. Okay. And we know this sigma square over n. Okay. It's the variance, how the spread the data is, because we know the sigma over the n, we exactly know this shape. Okay. So if you want to say whether it's more than 6, right? So it must be the case that if this is sufficient larger than 6, right? Sorry, not 7, but here's 7, right? So the question would be, is this 7? It's on the color maybe. Is it 7 here? Okay. The question is 6 and 7 large enough to call the evidence sufficient to support more than 6, then equal to 6? Okay, remember this overreaching goal. Okay. The idea is to discuss how far it is. Look at this area, right? Is this area more than 5% alpha? We usually adopt, right? It's more than 5% or not? More than 5%, then we still say it's not big enough, right? The distance. If less than that, it's big enough. So that is an overreaching criteria. Okay. So how to do this, right? Is it more than 5% or not, right? The question is, right? And usually we don't work on this one directly. Instead, we work on the Z, right? As I said. And this will be converted to 0. Okay. And what is this guy? What is 7? 7 is 1 above the mean 6, right? And to look at distance, you have to look at how the spread the data is. The spread data is for 64 is 1/2, right? SD is 1/2. Okay, the bell has the SD of 1/2, and 1 and 1/2 means that actually it's 2 SD from the mean, right? That's what the Z-score is. Remember, Z-score is how many SD from the mean. Okay, plus means above, negative means below. Okay, it's 2 SD above the mean. Okay, and then the question now, we know the 2 ways to touch this. Either we look at this value, right? That's we call the p-value method. Look at this area. Is this more than 5% or not, right? And the way you do it, right, will be, as we said, we can look at the p-value here, right? It's a norm. We use the norm, right, as this, right, and 2 true. Okay, so because we're looking at this, right, 1 minus. Okay, so this is the area exactly. We compare this with 5 or not. Okay, and why this guy, right? Just look at area on the left hand side. 1 minus is the right hand side. Okay, and you compare this to the 5% or not. Is that clear? Okay, this is one way, and this is the usual way we do now with Excel. So this is the standard one. Okay, and the other way around is more classical one, which is the first bullet point. Do is look at the critical value. Okay, the critical value method means the following. I do try to do this is look at what value this gives you 5%. Okay, and if within this region we reject, right, we'll define the rejection region. Okay, this is the critical value method. Okay, you do one of them. How to take this 5%, right? We will just do, because the right hand side is 5%, the left hand side is 95%, right? The total is 100. Okay, so that means that I would have norm as standard normal inverse. Okay, because 5% on the right, 95 on the left. Okay, then we'll give you this value, which is 1.64. Okay, so exactly as I drawn. Okay, and 2 is above 1.64, right? So you would reject. Okay, if you ask me which one you prefer, doesn't really matter. Okay, you can just pick the one you like better. And since now we have Excel pretty easily, or calculator, p-value is preferred in most of the time, because we exactly pinpoint what's going on, right? Do note that the decision you have to write is this, right? You have to write reject H null at 5%, right? This is the thing we're asking. Okay, this is your decision. Okay, you reject H null. Okay, so that is the idea. Okay, so the decision is whether to reject H null or not, right? We reject or do not reject. Okay, the conclusion is. Okay, remember there's 2 bullet points. You can only do one of them, not do both. Okay, just one of them is enough. I mean, you can do both, but you only need one. Is that clear? Okay, I know it's I'm repeating a little bit, but it's necessary to make sure everyone in the same place, because this is we will do again. Okay, if there's no question, we do the thing on the left again. Okay, I'm pretty sure I'm repeating a little bit more than necessary, but I hope that to ensure that I have 95% that you are okay. Okay, because I'm pretty sure no matter how much time I repeat that, I will lose some people, because when I learn this for myself, it took me a long time. Okay, but even though maybe you miss some of the technical detail, hopefully at least remember the mechanics or algorithm to do it, because it's rather standard. Okay, because we do more time, then you understand, then you appreciate the logic behind. I try to give the logic, but sometimes may be very difficult. So this one, the idea is just opposite, left hand side. Okay, I try to go to example and try to justify again. Okay, so the idea is I have a data, right? and the goal is try to test whether the population mean is 6, right? And because normal, okay, and that means that X bar will be a normal, okay, and we hypothesize under H null this is 6, okay, and since we know the sigma and n, we exactly the shape, right? How fat is the shape is we know, right? Because sigma square and n we know exactly, right? Sigma is 4, n is 64. Okay, so that is we know how this shape looks like. Okay, and the question we're trying to answer is whether we would prefer to take h0 or h1, right? h1 is the case where it's less than 6, whether it's on that side. Okay, because of randomness, you know, it can be above 6 and below 6, right? It's natural. And the question is how low below that you will take h1 rather h0. Okay, so that's a question. How low is too low? Okay, and we call that we would deciding by how low determined by probability, right? If this probability is less than our pre-specified alpha, which usually is 5%, okay? But in the exam, I may ask 10%, 1% to make sure that you know, right? So like likely I make 5%, but maybe, but I would be making 10%, or don't be surprised I ask 8%, right? I would just try to have track, right? But that would be the idea, right? It's low enough, right? If low enough, then we're done. Okay, we would take this rather than this one, right? So just to test your understanding, if X bar is 7, okay, then what you do? You would just go home and drink coffee. Why? Because 7, you will not be less than 6, right? Then you're done. You don't have actually need to do anything, right? But only sufficient less than 6, you would be actually doing something, right? Make sure that you understand what's going on here. Now, what we do is instead of the X bar, we look at the Z, right? There's a standard technique, right? We will just normalize this, right? This become 0. How do we do this, right? We will do X bar my whatever the value here, right? How to convert this is to whatever value X bar will minus 6, right? And over half, right? Because you look at the distance between the mean over the SD, which is 1/2, right? So, and the data what we have is actually 5. Okay, we don't know 5 is here or 5 is here, so that's a question mark, right? If 5 is in the red region, then we are happy, right? And the 5 turned out to be -2. Okay, because 5 minus 6 is -1. -1 over 1/2 is 2. Okay, so we know 2 is here. So the question, very simple. We want to see whether 2 less than -2 is less than 5% or more than 5%. Less than 5% means it's too far away from 0, which is too far away from 6, that we will reject. We'll in favor of X1 instead of X0. Okay, so we want to see whether it's less than 5% or more than 5%, right? To test this area, remember the normal. Excel actually directly gives us an area on the left, right? Which is norm, okay, as this, right? And then -2, and then true. Okay, so this exactly gives us what we want, and you can try Excel, which is 0.0028, right? And that is 2% less than 5%, right? Then you would reject X null, right? If alpha you are choosing is 5%, if your alpha is 1%, what do? You will not reject, right? Because 2%, right? You choose 1%. If you choose 10%, then you will reject, right? If your alpha is 2%, what you do? If alpha is 2%, then you would not reject, right? We used to not reject and reject. Sometimes they talk because accept usually is a weird thing, but terminology you can say accept, there's no problem for my class. But you go to statistics, they will very be picky the word never accept anything. You only reject, right? Okay. You never say yes. Okay. I don't know, just terminology. Okay. So the other way one, as we said, is you can convert the 5, right? You can look at the 5. What is the 5, right? 5, what's 5? 5 is -2, right? And you can look at 5%. What's alpha? What's alpha thing, right? What's alpha? Okay. Alpha 5%. Okay. What's 5% here? Okay. What's 5% here? Okay. 5% here, you can use the critical value method, right? It's -1.64. How do I get that? Okay. Because left hand side is 5%. So the way to do is maybe here, right? I will do norm, okay, s dot inward, right? Because I want the probability go back to the number 5%, right? So it's 5%. Okay, that should give you -1.64. Is that clear? So one way or the other, you do. As I said, you can do this or that. Okay. The good thing about the critical value, because for the set is you don't really look at the table, right? Because 5% is always 1.64. You know it. Right? Frame says all the question, right? 5% one-sided is always 1.64. So that's why in the old days people prefer the first method, right? Because we can close our eye, don't need to look at the table. It's very simple. Right? Is that okay? I hope that is fine. Is that okay? Is that okay? No question? Do the two-sided one again. Oh, sorry. Is that okay? Okay, then I erase. So two-sided one will be slightly little bit more challenging for the p-value. Okay, the p-value we need a little bit tricky. We will have 2 times something. I'll explain a little bit more. So it's a slightly little bit crazy. Okay, if you do not think carefully, but if you don't understand, it's okay to at least to remember that. Okay, let's draw a picture here. There's no different from the previous question. Again, sigma is 4, n is 64, x bar is 5, and mu is 6. Okay, everything is same except this guy. Okay, so let us draw the diagram again. X bar is here. I have a bell. I have 6 here. I know how spread that guy is because I know the sigma, I know the n. Okay, I know how this thing looks like. Okay, the question now is we are not choosing one-sided, two-sided. Okay, we are not to decide whether it's equal to 6 or not. Okay, and it's too big or too small. We will be looking at x1 rather than x0. Right? So too big or too small, we don't allow. Right? We will try to see that. So that means that I would be thinking the case whether it's too big or too small. Okay, if too big and too small, then I'm not happy. Okay, so my choice of alpha, okay, because I don't know which side is going to be which, is symmetric. So I would equally divide alpha on the both sides. Alpha over 2 on the both sides. Okay, because it's normal, it's same size. So we just by convention, okay, we'll put alpha over 2 on this and alpha over 2 on that. Okay, so if it is too big and too small, okay, then we'll reject. Is that clear? So how far is too far depend on the probability you assign. It's called alpha. Okay, and because of two-sided, it's alpha over 2. Okay, do not be careful. It's not alpha on both sides. Alpha over 2. Okay, because remember what is alpha 2? Because alpha is a choice of type 1 error. What's type 1 error? Type 1 error is even though this is correct, right? Even though it's 6, it has probability go up and down, extreme value, right? It's alpha. So that is the value. So that's why alpha over 2, right? Because it can up or down, right? Extreme for the extreme value. So the procedure is same. What we do is to convert that guy to Z, right? The data we have is 5, right? So the color, the data is 5 here. Okay. 5 here. The question is whether 5 is in here or in there. So that's a question. Okay. I don't know 5 is here or there. We don't know. Okay. So let's look at the curve here. Okay. Again, 6 will convert to 0. Remember how we standardize normal is asking the distance from the mean, right? Minus the mean over the SD. SD is one quarter. So again, this is 5 is -2. Okay. Now, here comes a slightly challenge. Okay. Because we are not, the p-value is not just this guy. Okay. Have to be very careful. P-value is not this guy. It's not just this guy. Okay. The p-value will be this guy times 2. Why? Because we are looking at what p-value is. We adjust the alpha such that it just got rejected, right? But before we do that, the alpha is just with 2 sides. Okay. So when we do it compare with the alpha, you have to multiply by 2. Okay. This is by convention. Okay. You can either compare this to half of alpha. Okay. But the way we define p-value is just the alpha such that this just reject. Okay. That's the meaning, right? The smallest significance value that we just reject it. Okay. So that means that we have to calculate 2 times. So that means that the p-value, okay, to calculate is considered symmetrically. There's 2 here, the 2 area add together. Okay. So if you go to Excel, you will be normal, okay, standard distribution, okay, -2, true. Okay. Remember, this is not done yet. Multiply by 2. Okay. So if you do 2-sided, okay, p-value is always double. Okay. If you don't recall what's going on, you just multiply 2, whatever. Okay. I think I remember the formula, but it takes me quite a while to understand what's going on. Okay. If you don't fully understand, just remember that will be done. You'll be done. Just areas multiply 2. Okay. If you really don't forget, you don't remember the definition of p-value, but that's how you do. Okay, is that clear? Okay. Again, we're 4%, 4.5% here. If 5%, you reject, right? If 1%, you do not, right? 10% of course reject as well, right? Is that clear? So you 4%, then you don't reject, right? 3% you don't. 6, then you reject. Is that clear? Okay. Now, here comes the next part is the how to do critical value. Okay. Critical value again is slightly a bit difficult. Okay, slightly difficult again because it's 2-sided. Okay. And remember, we want both sides alpha over 2, right? Alpha over 2, alpha over 2. Okay. That is set here, right? Okay. That means that we're looking at z alpha over 2, right? And this number is negative z alpha over 2. Okay. And how do we do that? This easiest look at this guy. Okay. Either way will be do because symmetric. Okay. If alpha is 5%, okay, alpha over 2 is 2.5%, right? 5%, 2.5%. So how do you get this number here? That means very simple, right? From area to number, use the inverse, right? Norm S inverse, right? If you use 5%, 2.5%, then there's 2.025. Okay. If you are curious, you can check this out. This guy will be norm S inverse 0.975. Because the right hand side is 2.5%, right? The left hand side will be definitely 97.5. Okay, I hope this become clear. This is the way we do. Okay, is that clear? Don't worry, we'll do the t-test again. Use the same procedure. Okay, but we're looking at different bell. Okay, is there any question? If no, let me go to the t-test. I do the right hand side, then we'll break. Okay, so because I hope to give you something new before the break, because otherwise probably you would be saying that I review too much. Okay, make sure that everyone have something new to learn today. Okay, is there any question? As I said, this is the last class that we focus on new challenging thing. Next class will be just applying what we have learned into different contexts. But okay, any question? If no, then we go ahead. So it's called the t-test. The t-test is just basically based on the idea when we do estimation. If we don't know the sigma square, right, we use the sample variance. When sample variance, this guy no longer follow a bell, but a fat bell called T. Okay, and one thing is have to be very careful. The fat bell is not just one fat bell, right? Normal has just one normal, and the fat bell, the T bell, depend on sample size n. Okay, and which one you pick up is n minus 1. There are many versions. The version you pick up is n minus 1. Okay, let me go to example. It'll be very clear. So don't worry. The procedure wise is very similar. So there's nothing new here. Just another Excel function you to check, but otherwise we're saying. So let's look at this one. Okay, you will see the similarity, then you will see things getting slightly boring, but I hope that you will stay with me. Okay. So again, I follow normal. I have n x bar. Okay, and mu is 4. The only difference now is I no longer have sigma square. Okay, but first we still draw the same graph again. X bar here, we still have that. This is 4 here. Okay, if we know sigma square over n, then we're done, right? Because this is exactly the same question. Okay, and again we're asking whether this is more than 4. Okay, so as we said, if this is large enough, then we are going to, right, this large enough or this area small enough, then we're going to favor x1 rather x0. I hope this stick in your mind why we're doing this, right? But the fact that we can't use this directly because we don't know sigma square. We don't know how fat is this bell curve, right? Without doing that, we cannot not know this area. So what we're going to do is use the result that has been proved. If we don't have sigma square, we use S. But when use S, it's no longer the bell curve is no longer the one we used to. We have to use a T1. Okay, and T is the n minus 1 version. Okay, and that's still a bell, but a much fatter bell. Okay, you can see the much fatter, right? This becomes 0. Okay, and as we said, the question is whether the 5 is here or 5 is here, which is the question we don't know, right? Whether 5 is in the blue region or not. Okay, but we can convert 5 into this here. Okay, 5 here. How do you convert it from this to here? It's by looking at, again, the same question, right? Just replace sigma by S. Okay, and again, it's divided by 1/4, so 1/2, right? So it's 2. Okay, so you convert that 5, actually it's 2 here. Okay. Okay. Now the question, use the p-value method, would be asking, what is this area, right? Is it large enough, right? And that's the question. Okay. And if this small enough, then you reject, right? So that's our criteria. How do we do that? Okay. If we know, then will be the 1 minus norm as this, right? But now we are not, we have T with 1 minus T this. not the norm as this, but T this. Okay. And against 2. Okay. And we're looking at T is a little bit different. The fat bell, the T, has many versions. Which version look at is depend on the sample size. If I have 16 sample, I look at the 15th version. Okay, that's we learn from the interval estimate, right? So I look at the 15th version. Okay, I use the true. Then we're done. Okay, this value 5% is the benchmark. Turn out to be 3%. Okay, so you would reject, right? Because it's too small, right? Another way to do it is called critical value method, right? After that, we'll break. How do we do that? Okay, what we're going to do is looking at this, right? What is the 5% here? Okay, what's this value? Okay, and from area to the value below is what we call the inverse, right? If right hand side is 5%, the left hand side is 95, right? So just T dot inverse 0.95. Okay, do remind yourself the T bell is a fat bell, have different version. The version we pick is 15, which is n-1. Then we're done. Okay, and this value gives you 1.753, which is less than 2. So as the picture shows, 2 is inside this region, so you would reject at 5%. Okay, and of course, if you use other percentage, then you have to change the number, right? Depends on what is the area. Okay, I hope that's okay. Is it clear? If no question, then let us have a break of 50 minutes. Okay, I'll keep this screen for 5 minutes, and then I'll open the U reply. So we will resume at 11:35. Yes. Oh，因為你撳計數機咧左邊噶嘛 ，distribution 係計 less than or equal to 噶嘛 ，F 你個 norm S of this
嗰個係講緊左手邊 less than or equal to。咁你撳機嗰時咪撳呢個數字咪得咯。如果大個嗰陣時你先買，如果你計大個你先買，如果一價。細個就係亂計機噶嘛，你呢個就直接撳 long this， 係啊，就咁撳 long this 就得噶啦。你個右手咪係啦，咁你要計翻右手邊，即係個圖係啦，冇錯，就係咁簡單。因為你嗰個計數機，我哋講 M 個定咧就係講左手邊。
跟住另一個我想問嘅就係幾時係即係幾時係零，幾時係一？係
大個9咪梗係硬地。你個零喺度，你大個嗰筆係個數字低嗰嚿嘢，咁梗係冇機會㗎。係啊，細唔即係你畫圖你畫個標出嚟先。你嗰度中間係零啊，9喺邊個位？你諗試？係啊，咁你大過9嘅之後，佢有機會啦。畫圖千祈唔好諗畫圖，要畫出圖你就明白，冇記係記唔到㗎，人個腦係好有限嘅啫。盡量畫圖，盡量所以我盡量講你個 principle 俾你聽，唔係俾你記啊。你明白個原理就可以知道容易啲嘅，用咗記嘅。呢3到分啊，好似有問題。啊好，有10幾100零係啊，嘅話就係話你個旁邊即係話你個 bell 上啊，即係有冇睇啊？但我仲未正讚，下邊第一個數目，下邊你 set 到個你個 area 0.5蚊比較，有啲set 啦，升噶嘛，即係一定遲早上面嘅 area。呢個2，我想問你係咪呢個area 個數字？呢個就係話俾你聽 area 好大俾我算，你個 area 多數呢啲就係反轉咗嘛。呢個就係呢個。我唔俾你問嘅，如果唔俾你揾表啊，你寫到方面嚟試試啊。我睇落佢出嚟一樣。但係佢 comment 呢個句，你幫我知道咁多個 population 係哦，係呢個呢個先啱。有個天，但係其他人冇嘅寫啱嘅。standard 呢個係有咧。Make sense. That proves those thoughts 嘅咩用啫？係啊，呢個要係唔知講唔係拗好遠。呢個就係咁樣嘅，我呢度係想講呢個。係啊，第2個係嘅。仔細咩？係差唔多啦，都 exactly 都咁即係。但係呢個都係大嘅。係啊，嗰個即係啲嘢非常之傳統嘅，好似達成啊咁嗰啲，因為咁就唔係全面係啊，咁都唔好先。係啊，我一去嚟㗎。我跟住嗰兩個大咯，係咯。即係你有冇計咁日數機？我唔知啊，如果係，所以你呢個，我哋你呢個係啱嘅 shape 都係 red。係啊。跟住我我唔知道。 我浪咗都自己調翻嘢，自己就我想個人就唔需要做。
講呢工作嘅問題就係佢哋咧晏晝要
分工冇 interview， 這個我通即係咁樣。
Let me open the reply.
T 嗰啲全部都係 Excel 嚟嘅，但係我最一次我先用 Excel， 或者寫晒啲事。四種第三題。機會係零，即係波實嘅，波實本或者係工作嘅，波實即係佢係啱。
It's really the first time, then I know how fast and how slow you're working with.
Đại công依個問啊，成日都唔出啊，好大，唔識食。我俾你投票啊！因為其實
應該大啲出咗身份。
And so I come to make and the steps of this and then I found to question
你 relevant 覺得呢個唔好食，兩個拍咗個二拍俾佢住。要知啊，你我冇知 relevant 到。That's good. That's good.
It's a very nice summary. This is business what we're doing a second summary, right? Even the call, right? They have a summary, right? Yeah, at the beginning. Yeah, you have to complete the call.
How do you centralize?
So we just
靚到就一入就發，一入就 B.B.A 就嘅。哦，sorry， 我唔係要2010，有時係我唔讀咁樣。係我驚好多呢啲高二啲嗰啲 rap 咗咯，我讀啲4就 真的，我真咱们写出来，係啊，之後再 intern 做得忙啦。哦，咁係，咁啊，係啊，成日分得自己數路上咯，所以咪但係咁你有開到幾癲喎，國家癲。係啊，好癲。同埋癲地咁嘅。咁佢4年嘅，4年之後繼續係埋女仔啊！而家唔辛苦啲就實有，以後就更加辛苦。大學辛苦啲咯，你都花咗10幾年嘅大學。係嘅，都花咗你最後嗰4年辛苦啲咯。唔係呢個太耐，我咁樣學入去。一出嚟而家就真係要 active 嘅。如果唔可以係啦，喺大學混，喺大學太得閒嘅啫，以後就得閒。一係你就好得閒，一係就好鬼忙，有兩個選擇。如果你而家唔忙嘅話，一係就冇嘢做，一係就死。呢個世界。好難撈㗎，而家最係好多專才嘅，一難撈到嘅，真係學大學啲學生好勤力㗎，你哋少啲都唔掂㗎啫。一大學生就少，啱我哋嘅幾多香港人，第一個我哋佢哋差唔多，而家多咗嚟咗個得兩個啫，其他都唔係收埋，都我個人。哇哦，搞掉啊！我來看得而家就看到邊個？其實我食 lecture 講 professor 考試冇教，我都冇獎，好靚。哇！我起碼都要1啦，真係好大啊！
So let's see what we got here. Oh, so someone have give up this class. So if you give up, I hope the minimum thing you do would be to look at the assignment, look at the green box, and make sure that you have reasonable grade to pass, right? Hopefully, at least I can give you a pass from this class, right? Because yeah, life is tough in this class, but the real life is more tough, right? Unless your home has many gold mines, otherwise, life is tough, right? As we know, right? Hong Kong now invite global talent, right? So your life will be very tough, even tougher, right? Is it extend deadline? What deadline? Project? You want project extend a little bit? Yeah. Okay, I would talk to the other section if they okay that extend. No. Some people say no. I mean, but I would ask if no one say no, that extend. How many time you want? How much time you want?
As long as you pass it.
1 week, is it enough?
No.
2 weeks.
2 weeks.
I have to check because I have the last deadline to submit the grade. Okay, because I have deadline to submit the grade as well. So I would try to see 1 week if possible 2 weeks. But they also ask at that class as well. Okay, I try to do that. Okay, but do note that I do not have freedom to extend that long. I mean, I have to check when to submit. Then I will allow me because I have to have a deadline as well. So I mean, so I try my best. Okay. Good. So hope you don't give up your project. Okay. I mean, I talked to some of you already. Many of you have done it almost. So it's very good. So hopefully you also make it work out. Oh, today is not Monday, to make sure that everyone aware. Today is Wednesday. Yeah. So yeah, chapter 6. I think it's wrong for this one. You're doing the topic 6, but that's okay. 1. Yeah, x1, x0. Okay. Okay. Oh, this is good. 1 point that you learn is 1 point, key point you learn. Okay, that's good. Self-referral. So one of you said it's a little bit too fast, but I try to be make sure that I okay. I think I will try to be a little bit make it appropriate. Okay. Some of you say my class is not okay. I try to a little bit slow a little bit. According to study, most of professors never work in industry, and they teach using Word. Oh, that's interesting question.
Good joke.
Well, we're gone. We go back to this. Again. So we borrow our tuition, so I can get. Yeah, that's natural. For me, I didn't borrow, but I work my way out. I do part-time to pay for my tuition. So same, but probably can I extend? Yeah, I will try to extend. Is it a joke or you want me actually extend or not? So that's a question. Is it? Should I? I don't know, but I will try to make at least 1 week. I don't know, it's more. Today is so cold. Yeah, long sleeve. Because I just come back from the north, Shenzhen, so that's why I have long sleeve. But it's not that cold. But yeah, finals a project. It's very stressed. I understand. So that's why our exam is open book, open notes in only 1 hour. Okay, so hopefully that you don't feel too much stress. Okay, so just to remind you that if in case you can't really attend the final due to some various reason, contact the TA so that we are grouped together to do the makeup. Okay, so make sure that you do that. Otherwise, it will be. Yeah, I will try to delay that one. As I said, try to do 1 week at least. Hope to get intern soon. Yeah, I hope that as well. It's very important as a B school student. You have to get intern. It's equally important as for your GPA, as far as I understand. Yeah, cold weather, and actually cold weather make you less sleepy, so it's good for the lecture. Okay. Where is the according to the professor there? Okay. So previous joke saying according to the study, most professors don't really work in industry. How can we know what's going on? Well, I guess for my class doesn't really matter because statistics is applied everywhere in the industry. So I think definitely okay. And you don't actually need to work in. To B school, actually many of the teachers actually work in industry, but not for me. But very senior professor, they also have their own startup. But I think I'm pretty busy with research, so I don't do any stuff like that. But many of business school students do. Oh, sorry, business faculty they do. I hope that I do that. Yeah. So where am I? So let's continue our journey to the t-test. Okay. So we will do again our left tail test, t-test. Don't worry, it will be very similar. So I go again. Hopefully that you know what's going on there. Okay. So let me repeat what we are doing. Okay. But another context, right? It's a left tail test. Okay. So I have a normal distribution, right? And I have sample size 16, sample mean 3, and z division 2. And this is the mu 4, right? According to this, what we know is that X bar has a bell. Oh, sorry. Not very symmetric bell curve. Okay. Center at 4. Okay. And the question is, I know this sigma square. If I know the shape, then I'm done, right? The hypothesis we're looking at is whether h now is x0 is 4 or x1 is mu less than 4, right? So remember the idea is this sufficiently less than 4, right? If it is too less than 4, so much below 4, then we will say we will support x1 or the x0, right? That is the idea. Okay. So the idea is it small enough? Depend on is this area small enough? If this area is small enough, that means that it's below that enough, right? So that's understanding. Okay. And the how small is compared to alpha, right? Is larger or less than alpha? That's a question. Okay. Alpha is chosen to be 5%, okay, as usual, but we can use 10%, 1%. Okay. And because we don't know sigma, okay, the question is how can we do that? Is someone prove we don't have this, but we use S square, okay? The sample variance. That is another bell, is Pm minus 1. Okay. This is still a bell curve. It's 0. Okay. And our number is right. Remember our number is 3 here, right? There's 3 here, right? 3 is here, right? 3 is below. Is it sufficiently below? Okay. And for this 3, we convert it to here. How do we convert? The same. Look at how it is different from the mean, right? It's 1 below mean. And look at it divided by the standard deviation over the square root of n, okay, which is half, right? So it's -2 here, right? So this t value, right, again is asking how many deviation actually from that, right? Sample d. And just to recall, sometimes someone asked me this, sometimes this causes a standard error. Okay, but anyway, we want to know this area same as this area, so it's the same color, right? The same area, this area same as this area. Okay. And how to calculate this area? Because I have a number, calculate area is the distribution function, right? It's t this, right? Because I come from the number to area, right? So it's -2 here. Okay. The one I use is the 15 one because it's a fat bell curve. The fat bell, you have to tell them which version you're using. And the version we're using is the n-1 version. The sample size is 16. We use the 15 version, right? Because from bottom to the area, it's used like this. Okay. And I use true because I look at the F, right? And this number turned out to be 3%. So use 5%, you reject. 1%, you do not, right? 10% you also reject as well. Okay. This is called the p-value method, right? That's your conclusion here. Okay. And if you don't like this, you can use the critical value, right? You can look at Tn-1, right? Look at this is 5%, okay? Alpha 5%. What is this value here? Okay. The value here is called from area to the number down there is T inverse, right? 5% is 0.05. We use the 15 one, right? Okay. And this area, this number is this number. Actually, it is -1.753, right? This is 0. Okay. And to recall, the number we have is -2. Okay. So it's inside the rejection region. Okay. So either way, it works out. Is that clear? Just wait one minute before we go to the other one, because you can see the method we do is rather standard. Okay, we keep doing the same thing, but in other contexts. Is that okay? Oh, Discord. Is that okay? I hope that's clear. I would say it's rather boring, but sometimes you need to overcome the boredom. Is that okay? If okay, then I just erase this one and go to this. Yes.
Why that is CO plus 1?
Sorry. Why?
The T in first Y is CO plus 1.
Y CO minus 1, right?
CO plus 0.05 and 50.
Oh, Y 0.05 is 5%. Alpha is 5%, right? So that's why it's 0.05 is 5%.
But in first 0.95.
Oh, okay. So if you right hand, okay. The previous, okay, that's a good question. So before I do is this one. If I want this to be 5%, right? Then I have to look at the left hand side. That gives you 0.95. Because the T inverse is asking what is the area on the left. I give the area, you give me a number. Okay, let me repeat. The inverse is you give me the area on the left of that value. What's the number of that, right? So that's why in the right hand side I use 0.95, right? Because the area on the left is 0.95. Now I have the area on the left directly, so it's 0.05. But it's the same thing because 0.05 actually give you 0.95 actually give you this number is 1.753, right? So that is symmetric. Okay, this one gives you a negative 1. The same, that means the same thing. But you know what's why is the same thing, right? Because symmetric. Is that clear? Okay, very good. You ask question because please ask question like what you do because it's good. Then I know what you're missing. Is that okay? Okay, because as some of you said, you pay for the tuition. Just ask, right? If you are too shy or you don't feel comfortable to ask, you can ask the TA. Okay, after class, our TA is very helpful. So he's happy to answer your question if you need. Okay. Any question? If no, then we go to the other one that's more complicated. Is the both side T value. It's slightly the same, but this is a T one. Okay, same thing. Okay. And the idea is the same. What we have is again, I have X bar here. Okay. I again have the same thing. We know that under this guy, this is 4. Okay. Okay. And we know this shape, right? Under normal, is a bell curve. The bell curve will follow sigma over root n. Okay. We have sigma and we have, but we don't know sigma squared. We don't know how big or fat of this. Okay. What we know is the data we have known is 3. Okay. We don't know how fat this curve is. We only know this 3. The question is 3 sufficiently small enough to reject or not? Okay. So the question is this area big or small than alpha over 2? Okay. We are comparing alpha over 2 or not. Okay. Because we are rejecting on both sides. Okay. Okay. Because before we do it, we have to say whether we have to check alpha is alpha over 2 on both sides, right? So that will be our rejection region, right? This region will be too small, right? That's our decision. Okay. We are comparing alpha to the p-value, right? Not the area over 2. So that's why multiplied by 2. Okay. So just to remind you, two-sided is area multiplied by 2. Okay. So what we're going to do here is you convert this x to t. Okay. This 4 become 0 here. Okay. That's how you convert, right? And it's Tn minus 1. Okay. And what's the 3 here? Okay. 3 here is again, as we expect, is -2, right? It's 2 away from 0. Okay. So how do we do that? We have to calculate this area, okay, and multiply by 2. That will be our p-value, okay? Because remember, p-value is you adjust alpha such that it's just reject, right? It's the largest alpha that you will still reject, okay? So the p-value will be 2 times. Okay, this p-value will be, because area, right? We want area. We want the number to area. So it's T this. Okay, because it's area on the left-hand side, so we're just done. -2, right? And which version you're looking at? N minus 1. 16 minus 1 is 15. Okay, true. Maybe I don't need this bracket. Okay. So that will be the answer. Okay, just to remind you that we have 2 tail, multiply by 2. Okay, and now we have some interesting case. This is 6%. So 6% means you don't reject 5%. So you can't reject it, is actually 4. We will take x0 rather than x1. So we fail to reject, or we do not reject, right? Okay. Is that clear? Is that a question? If no, then talk about the other method. It's called the critical value, but the same idea as we have seen, right? We look at T15, right? Look at the fat fail, which is 0. Alpha is 5%, right? Look at the rejection region, which means that I want, right? Here, add up to 5%. So this is 2.5%, right? Or 0.025, right? This is 0.025. Okay. How to find this number here? This number will be just from area to number. Down there will be T inverse, right? The left-hand side is 0.025, right? We look at the 15 one, right? So this number there will give you -2, okay? 0.13, okay? So it's then this guy will be just T inverse 0.975, 15. Why 0.975? Because here is 0.025, right? Then the left-hand side is 0.9725. Add up to 1. Is that clear? Okay. And if you try to put this graph back to here, okay, we will see the critical values are here, right? So this is a critical value, right? And the data is -2, so it's outside the rejection region. So you don't reject if you use 5%. Okay. I hope that become more clear after we do so many. Is that okay? Is that okay? I hope that is become slightly more clear after we repeat many times. Okay. Any question? That's okay. I'm going to repeat myself again under context. So as I said, it's slightly more boring, but with the cold weather, hope to keep you awake a little bit. Okay. Good. Now, as I said, it'll be very boring. So let's repeat this one. So far we focus on data have no restriction, but now we should do binary data, proportional data. Yes, no question, right? Whether you like curry food or not, right? Whether you are male or you are female, right? It's 0, 1, okay? And we call that sample mean, right? It's just proportion, right? Sample proportion. Population is probability proportion, okay? The only difference of this is the mean and the variance are closely related, right? If I know the mean, I know the variance, okay? So that's why the good thing is I can always use normal, okay? Especially when sample size large enough, I don't have to rely on t, right? Because I know the variance, right? Remember why I use t is I don't know the variance, but under the null, I know the variance, right? When I know the mean, I know the variance directly, okay? I can directly use this, okay? Without going to t, okay? So that is the reason, make things easier, okay? You just need to know this is the formula, and then we're done, okay? Now let's go to the example. To save you from my repeat, I just focus on both two-side tests, okay? You can do the one side the same way, okay? The one side same, okay? Let's do the two-sided one. So now I have binary data, okay? And I have sample size of 50 and proportion of 0.5, okay? This is my hypothesis, okay? So this is the hypothesis we'll be considering the percentage of boys in undergraduate in CHK, right? At least in B school, right? I think it's 40% are male, 60% are female, right? That's what happened. And I want to see, I look at data, turn out to be half of the sample is male, half the sample is female, okay? And is it sufficient to reject this, okay? In favor of the other one, okay? So that's a question, right? It's very standard question, right? I just look at, go to the business school canteen and this is what I do, right? So the question is the P, right? According to this, I expect around 0.4 here, right? And do note that because of binary data, we know the variance will be 0.4 times 1 minus 0.4 over n. Okay. That depends on n, of course. Okay. The bigger the n, the more it collapses, right? Is that clear? Okay. Do note that this is a special property of binary data. Okay. So this is always a normal bell. Okay. So what we do is we see our data turn out to be 0.5. Okay. The question is this 0.5 sufficiently different from 0.4, right? Remember, it's two-sided test, right? We're actually rejecting on both sides, right? So if this is sufficiently small or sufficiently large, then we reject, right? We put alpha over 2 here, all right? Alpha over 2 there, right? If in the green region, then reject, right? Alpha is 5%, right? You took 2.5 on both sides. Is that clear? Okay. So again, instead of working on this P thing, we work on the Z, right? Z is here. The bell is here. This is 0 and 0.5. How can you convert 0.5? You just minus the mean, right? Over the square root of the SD, right? Square root of the variance, right? Turn out to be is 1.44 above the mean, right? 1.44 SD above the mean. So this 1.44. Okay. So if you use the p-value method, remember it's two-sided. Okay, two-sided. The area have to be multiplied by 2. Okay, just to remember this thing. What we have is this area, right? And this area I need to multiple by 2. Okay, that's the p-value. How to calculate this value? Is norm, standard, this, right? 1.44 true. But remember, this area, this value only gives us the left area. I need to 1 subtract to give me the right area. And then I need to multiply this by 2 to get the p-value. Is that clear? So it's slightly a little bit more complicated, right? But I hope that shouldn't be an issue for you for right now, because we have gone through many examples of this already. Okay. And the other way around, remember, we want to figure out the green thing, right? Let's do the green thing, right? What we want is the Z, right? This is 0, right? We want this area, this 2 area, right? Is alpha over 2, right? And this number is norm as inverse 0.02. Let me write that better. 0.025. Why? 5%, both sides, 2.5%. 2.5% is 0.025, right? And this guy is norm as inverse 0.975, right? So this area you go down is 1.96, and here will be negative 1.96, right? Okay, so that give us the rejection region, and 1.44 is within this region, so we really can't reject it. Is that clear? I hope this become clear, but of course you will do a lot of assignment, slightly repeating yourself, but I'll give it by the end of this week, because is that okay? Is there any question? Any question? Now you see there's still many slides, but don't worry. The rest of slide I'll go through very fast. Not today, but on Friday. But you will see it's very similar. So I'm not going to repeat myself too much. But what we'll do is you will see the same strategy, but the formula is slightly different. But the idea is very similar. Okay. So hopefully this will stick into your mind, and then we'll talk about that next class. We become more clear. Is there any question before we go? Okay. So I'm not going to bother you with new formula, but I want to talk about what's going to cover on Friday. Okay. So you can relax a little bit, because I will give you some idea what's going on. Okay. No more formula. I think your mind already explode somehow after intensive math class. Okay. 2 samples. Okay. So don't worry. You will see the thing is very similar. Okay. The idea is that so far we focus on one particular sample, and very often actually we will talk about comparing things in 2 samples. Okay. We want to see, say, in business application, we want to see, do we want to have a different marketing strategy in Hong Kong against Shenzhen, or rural area and urban area? Or you have a business in Hong Kong, do you want to set up different thing for the Hong Kong Island or Kowloon Peninsula? Or do you want to have a different business strategy for female customer versus male customer, so on and so forth, right? Comparing 2 groups, are they different? If different, you want to take some action. So the first 2 questions, first 2 bullet points, right? We want to know, I have 2 sample mean, right? I collect female customer, male customer. Are they different, the same? right? That's a question. Or the best standard is looking at the medicine, right? We have COVID, right? You want to ask whether having a mask and no mask are different. That's a question, right? And the 2 bullet points is asking whether you assume they have same variance or no different variance, and with different formula. So don't worry, just applying different formula. As you will see, it will look like this. Okay, what you do is the same idea. You will just starting x0, x1, calculate the variance. That's a little bit complicated part is the bottom, but the numerator is similar. Okay, so don't worry. We just keep you applying different formula to different scenario, and that's what we do. And the third one is called the pair population. Okay, pair population is mostly easily understood by looking at intervention by medical tests, right? You have some people who take the medicine before and after for the same person. You want to see whether medicine actually help or not, right? It's an intervention. It's a paired. Okay, you have one guy who take the medicine before you do a medical test. After you do it, you take a medical test, right? It's an intervention problem. And you also want to compare proportion, right? For example, you want to see if whether we have more female in accounting major than female in engineering major, right? So on and so forth. You compare proportion, right? Or you want to compare whether people who study math before to M1 or M2 before is performing better in this class, right? More like the LA or not. Oh, it's a good question. And lastly, we talk about variance. Okay, we want to compare variance. Okay, we don't say is this sample variance more than this sample variance. For those who are in quantitative finance, that's the thing you do, right? Because variance is the measure of the risk of the stock, right? So you want to compare which stock is more volatile, right? Or which portfolio strategy is more volatile. You compare variance, okay? And compare variance is a very important concept because for the ANOVA, which we cover next week, and the regression the way after will be actually the comparing variance. Okay, so I guess I should end now because usually I overrun by 5 minutes. So I guess it's okay. Let you go a little bit earlier today, but I'll stay here to answer any question you might have. Okay, so enjoy. I will see you on Friday, and we'll finish this. Then you have assignment. Okay, have a nice day.